It's been an incredible week here at the 2023 MRS Fall Meeting. We've seen so much learning, innovation, and celebration of the past 50 years of the Materials Research Society. As our time in Boston comes to a close, we're looking to the future to see how you can leave your mark on the world of materials science and engineering. Back for one last episode of MRS TV, I'm Katie Brace. It's been an amazing week here filled with cutting-edge research and exciting new ideas. In today's episode, we're going to catch a glimpse of what the future holds for the field. 2023 MRS Award winner Dilia Mil will tell us about her work in optically tunable metal oxide nanomaterials. Then we'll head back to Symposium X to see how Giulia Grancini is helping shape the future of sustainability. Plus, Von Hippel Award winner Reshef Tenny will tell us about potential medical applications of his work in nanoparticles. And finally, we'll head straight to the cutting edge to see how some of the world's top institutions are shaping the future of materials science and engineering. First, though, let's chat with Gopal Raul and Rigoberto C. Advincula about how MRS journals can help you cement your legacy in the materials world.
I have been with MRS for 26 of those 50 years. Also, my very first meeting was almost 30 years ago. So in one sense, I've been sort of going with MRS in its journey.
I can recall where I started as a graduate student way back 25 years, if I betray my age.
MRS Bulletin started as a small newsletter 48 years ago, when MRS was still a fledgling society. Both MRS and MRS Bulletin have grown alongside the field of materials research, I think.
The MRS communication is vanguard in terms of reporting the latest and the best of research, both fundamental and applied. The 50th anniversary is really a work that comprises of experts, editors, members, advisory board, also our award winners, so they contributed heavily in this issue. So looking at the accomplishments and the state of the art, it really is a wonderful contribution to the body of literature, and it's a joy and fun to work with them and assemble this collection.
So we wanted to do a couple of things. One, we wanted to publish a series of articles that celebrated the different topics that have been covered in MRS Bulletin over the past 50 years. And in addition, we wanted to also cover some of the newer topics that are really emerging today and that will be part of material science for the next 50 years. In 2025, MRS Bulletin completes 50 years, so we are planning a sort of celebration there with special issues, no doubt. We're still thinking about how best to do it, and we welcome submissions, suggestions from the community for the 50th year celebration of MRS Bulletin.
First up, from the cutting edge, Johns Hopkins University's Materials Characterization and Processing Facility is reimagining the modern foundry. The state-of-the-art facility boasts world-class instrumentation in a beautiful building. Let's see how they built the lab of the future.
At Johns Hopkins University's Materials Characterization and Processing Facility, we've created a research space by material scientists for material scientists.
The MCP was Johns Hopkins' search for a central facility. The challenge was to make it beautiful, but also functional. Our hope was that this would be a place that would allow creativity to blossom.
The MCP has really broadened the reach that we can have with our research and the scope of the research that we can do.
I hope that the MCP becomes a model for material science facilities and all scientific laboratories of the future.
The best in the world should come to Hopkins and the MCP because we have the best facility in the world.
Joining us now is Dilia Mil. She is the 2023 MRS Medal recipient. Congratulations.
Thanks so much.
So how does it feel to be recognized by your peers here at MRS?
It's really awesome to be recognized by MRS. MRS has always been an intellectual hub for me, really, since graduate school for my research. And it's a place for me of inspiration of new ideas and a sounding board for new results and things that we're putting out in the world.
So you're being awarded for your research in optically tunable metal oxide nanomaterials. Tell us about your work that led to this award.
So my group synthesizes colloidal nanocrystals of metal oxide materials. These are wide bandgap semiconductors, so they're normally transparent to light, but we dope them to make them optically active in the infrared with dopants that bring along extra electrons that generate a plasmon resonance in the material. And the tunability comes from the amount of the dopant that we incorporate during the synthesis of the nanocrystal that adjusts the wavelength of the plasmon resonance. We've also shown that you can post-synthetically change that amount of charge concentration in the nanocrystals, and this lets you dynamically modulate the plasmon resonance, and this is something that's led to new materials for smart windows that can on-demand control the amount of solar heat gain from the sun and daylighting coming into our interior spaces.
And you kind of touched on it, but can you give us a glimpse into what's on the horizon for your continued research in this area?
Yeah, so we're just at the early stages of learning how to further couple these plasmon resonances in our materials to other optical transitions. So for example, enhancing the luminescence from quantum dots or enhancing the sensitivity to detect molecular vibrational modes for sensors.
Well, thank you so much for all this insight and congratulations once again.
Thanks so much.
Now, let's pop into Symposium X one last time to learn about how Giulia Grancini is helping to usher in a low-carbon society by 2050.
I think photovoltaics can be a leading solution for next future energy generation, accounting for more than 40% of global energy needs. So it can be really a leading solution for renewable energies. And for this reason, I think it's really important to focus on new generation technologies and materials to really lead these game-changing technology for the future. Well, hybrid perovskites, that's the name of this new photovoltaic solution, has really boomed in efficiency in the last decade, touching now record efficiency which are comparable to standard technologies. So this is a dramatic increase in the performances that is really revolutionizing the field of photovoltaics and has attracting a lot of interest worldwide from a research side, but also from industry. That's very important now to translate this technology from research lab to a commercialization. So this attracted a lot of interest because of the efficiency, but also because of the extremely interesting properties of the material itself, which can really make a kind of a revolution in the field. We know very well that this MRS conference is one of the worldwide most important conferences on materials and technologies for energy. So it's very important to share new results with colleagues working in the field to advance in a timely manner these materials and this technology. So with the sharing of science, sharing of knowledge, and having feedback from different leading researchers who are all here because of the importance of this community and of this conference, I think science can really advance, and we can make a big change in the future of photovoltaics.
MRS Communications launches a new article type for publication in 2024, Methods Letters. This is an exciting and unique opportunity in materials literature for rapid dissemination of letters-length papers on new or improved techniques for characterization, instrumentation, materials preparation, analysis, application of machine learning tools, computational methods, and other key elements of experimentation. Submissions are open now. For more information and a technical description, go to mrs.org/methodsletters.
Your registration for the fall meeting includes a one-year complimentary MRS membership that starts on January 1st, 2024. That also means you have free electronic access to all MRS journals and will receive discounts on registration for future meetings and workshops.
It's not too late to submit an abstract for the 2024 MRS Spring Meeting in Seattle. Breaking news abstracts will be accepted from December 15th through January 9th. Find out more at mrs.org/spring2024.
Your registration for the Boston Experience also includes access to the virtual experience, December 5th through the 7th. Tune in to live virtual presentations of fresh content, connect with peers, and access on-demand content from all symposia. On-demand content will be available for viewing in the virtual platform through January 31st.
Thank you to our 2023 MRS Fall Meeting Chairs, Daria Baran, Alexandra Boltaseva, Julian Pernot, Christopher Reyes, and Jonathan Rivnay for all of their hard work in ensuring the success of this meeting. Pulling together a meeting of this magnitude is no easy task, and these meeting chairs have worked for 2 years to bring you this event.
Let's head now to Hong Kong, where the Nano and Advanced Materials Institute has long been on the cutting edge of innovative technologies. Let's see how they're bringing nanotechnology to local industries across sectors.
Over the past 17 years, Nano and Advanced Material Institute has been conducting market-driven applied research on materials to support the industries. We are successfully undertaking more than 200 R&D projects in collaboration with the industries.
NAMI support our industry partners in technology transfer and scale up for commercialization, like using our nanofiber technology for developing N95 surgical-grade face masks, lightweight concrete for modular integrated construction, and innovative battery materials for long-life battery for IoT.
We have cutting-edge research facilities worth over 400 million Hong Kong dollars for material synthesis, processing, and characterization. Our main target is to bring new material technologies from the lab to the commercial market, and we work closely with our industrial partners to ensure successful commercialization.
We are excited to sit down with Reshef Tenny, this year's winner of the Von Hippel Award. Thank you so much, sir, for taking the time.
Thank you very, very much.
And congratulations.
Thank you very, very much.
So your discoveries in nanoparticles in the early 90s were hugely influential. What initially drew you to this area of research, and what's kept you there?
Well, I was looking for interesting solar cells in the beginning, and I worked on solar cells at that time, and I decided that I will try to go and grow thin films of these materials, tungsten disulfide and molybdenum disulfide, which were not that popular at the time. There were only a handful of groups, scientific groups that worked or researched on this area. And then I came across the work of Sumio Ijima and Kroto on C60 and on carbon nanotubes. And I said to myself, hey, if they can make it on carbon, I can do that for any layered compound. And all these materials are layered compounds, compounds with layered structure like deck of cards. And if they can do that, if they could do that from carbon, from graphite basically, I can do that from molybdenum disulfide and from tungsten disulfide.
So your award lecture was about Misfit layered compounds. So what does Misfit mean in that particular context?
Among them, we synthesize so many nanotubes from so many compounds, layered compounds. And in the last 10 or 12 years, we focused on Misfit compounds. Misfit compounds are basically intercalation compounds. You take a layered compound like tantalum disulfide and you intercalate, or you insert a layer of lead sulfide or tin sulfide or lanthanum sulfide, and the stability of this Misfit compound is gained by the charge transfer from the lanthanum sulfide to the tantalum disulfide, layered tantalum disulfide. So it's basically an intercalation compound which has a misfit in the structure. The notion of misfit means that they are non-stoichiometric. They are not, the lanthanum sulfide and the tantalum disulfide have no common unit cell. And so they are misfit, and this is the source of the name misfit compounds.
So what possible medical applications are coming out of this work?
First, for lubrication. Lubrication is very, very important in several treatments. For example, if you want to insert a catheter or any endoscope into any constriction of the body from the top or from the bottom, you need to overcome very strong interaction between the insert and the body. And there are many other examples. For example, last week we published a paper with a group in the UK where we use chitosan. We reinforce chitosan. Chitosan is used for packaging, food packaging, for variety of medical application, packaging of medical products. And if we can use these nanoparticles first to reinforce the polymer to be more durable, and secondly, to have lower permeability of oxygen and CO2, it will enhance dramatically the packaging industry of medical products, for example.
All right, fascinating. Thank you so much for taking the time. We appreciate it.
Yeah.
We're closing out today's episode with a visit to Lawrence Livermore National Labs. Their Materials Science Division is a cornerstone of cutting-edge research across the entire spectrum of the fields.
The Materials Science Division is a vibrant, enthusiastic, and dedicated group of scientists and administrative staff that serve the purpose of addressing the lab's needs in materials science. The nation relies on our expertise and capabilities in materials science as it applies to stockpiled stewardship as our primary mission. The division covers a wide range of material classes as well, ranging from actinides to high explosives, optical materials, polymers, composites, and a number of other material classes.
Material science seems to be at a crossroads right now, with the confluence of new technologies really coming online to bring us into the future. Technologies such as increased automation, use of artificial intelligence, in situ monitoring, advanced manufacturing, we believe will come together to really help us with our mission of accelerating the design, development, and deployment cycle for new materials and applications.
And with that, the 2023 fall season of MRS TV comes to a close. It's been an incredible week here in Boston, and we hope you have so much new knowledge and so many new connections to keep you active and inspired. This may be our last episode, but you can keep watching MRS TV on screens around the Hines and Sheraton, in your room at select hotels, on the MRS meeting website, and on YouTube and X, formerly known as Twitter. We'll be back in April for the 2024 MRS Spring Meeting in the Emerald City, Seattle, Washington. We hope to see you there. Have safe travels back home, everyone. I'm Katie Brace, signing off.